Hello everyone. This week I will start a new playlist which is Applied Medical Statistics for Practicing Physician. Also, it's useful for medical students, for any medical practitioner, and also for board exam takers because this is a basic knowledge usually tested in all the medical exams. This playlist will not provide a comprehensive statistic presentation. It's rather a concise refresher for the practical application of statistical principles and concepts in medical care and clinical research. So let's get started. First, let's define the applied medical statistics. It's the application of statistical methods to medical and health sciences, and it involves the design, analysis, and interpretation of data from medical research studies. It involves also understanding the effectiveness of treatments, predicting disease risk, and making informed healthcare decisions. The contents of this playlist would be overview of common statistical terms and concepts, review calculations and common statistical tests, providing examples of statistics in medical care and research. So in this presentation, I will start with the 2 by 2 table. For its important, in spite of being very simple, it's very important and a powerful tool used in medical statistics to summarize the relationship between two categorical variables. And it's very essential to calculate a lot of epidemiological and clinical research tests. So that's why I wanted to start with the 2 by 2 table. So here we have the 2 by 2 table. As you might realize, it has more than 2 by 2 cells. That means more than 4 cells, but that's because we have the labeling of the cells and we have the totals, and we need all of that. So the name 2 by 2 is for the A, B, C, D cells that you see in the middle of this table. And I want to highlight one point that it's crucial to label the 2 by 2 table correctly in order to get your answers correct. Why? Because if you mix up the labeling of the rows and columns, the answers eventually will get mixed up. So the standard way is to put the disease and non-disease on the columns, which is the vertical lines. As you see here, disease positive usually goes first, disease negative goes second. And you put the exposure and non-exposure on the rows, and that's the horizontal lines. It's very important. As I said in the beginning, it's simple, very simple, but it's very crucial to have it right from the beginning, because in the calculations, as we will see in the future, it all depends on where you put the numbers. So please stick to this standard labeling. Have the disease and non-disease vertical on the columns, and have the exposure and non-exposures on the rows, which is the horizontal lines. Sometimes it depends on the type of study. It will not be exposure, non-exposure. It would be intervention and non-intervention, right? And we'll see all of that. Let's go ahead and understand why it's very important. So here are some examples of the tests that we need a 2 by 2 table to calculate them. We have the odd ratio, relative risk, all the other risk, attributable risk, and number need to treat, number need to harm. We have the sensitivity and specificity. And I believe any exam in your medical career will ask you about these two terms specifically. We have also the positive and negative predictive values. These are some of the main tests and epidemiological measures that we need the 2 by 2 for, and that's what we will be discussing in this playlist. So let's go practical and start with an example to understand how to fill the 2 by 2 table and how to calculate the, for example, this example will ask you about the odd ratio. So we will start one by one and we'll do the odd ratio in this presentation. The example says a study was conducted to investigate the association between smoking and lung cancer. This is usually the test used in most textbooks to explain the 2 by 2 table because it's famous, and the relation between smoking and lung cancer proved a long time ago. So it says this study found that 15 out of the 20 patients who have lung cancer were smokers and 30 smokers among the 80 non-cancer individuals. And I highlighted the terms, the key terms with different colors just to help you fill the 2 by 2 table. Here I said create a 2 by 2 table for this question, then calculate the odd ratio. Honestly, in any exam question, they will not ask you create a 2 by 2 table, but eventually you need to create the table in order to get the answer. So I just put it here to remind you that in such a question, you need the 2 by 2 table. And here we go. We put the table the same way we said, and we start filling the cells. The cells, A, remember A in the left upper corner, B in the right upper corner, C in the bottom left corner, and D in the bottom right corner of the 2 by 2 table. We're talking about the 4 cells in the middle. And you, from the example that you have in front of you, you understand the wording very specifically. Your understanding for the words is very crucial to fill the table. So usually you start with the given information, and here they told us we have 20 patients who have lung cancer. So we go ahead and we write the total of lung cancer patients as 20. And the question said 15 out of these patients were smoker. So we know we have lung cancer patient 20, and we know the exposure, which is smoking, is 15, because this is what they give us. So the five you see here as the non-smokers, but they have lung cancer, is something that we conclude from the information given to us, because we know 20 total have cancer and 15 are smokers. That means five are non-smoker. This is something you conclude, and you immediately put it on the non-smoker lung cancer cell, which is the C cell here on the left bottom row. All right, and the question also says they found that 30 smokers among the 80 non-cancer patients. Again, we know as non-cancer, which is lung cancer negative, we have 80 patients. The question informed us that 30 of them were smokers. So we go ahead and put the 30 on the B cell, which is here on the top right cell. I'm talking about the B cell on the 2 by 2 table, and that's the 30 smokers, but they don't have lung cancer. And since the total of non-cancer patients are 80, that left us with 50 patients who are non-smokers and don't have lung cancer. Honestly, this, in spite of being simple, but it will give you all the answers correct, because the calculation is simple calculations. And usually in every test, they give you round numbers or simple numbers that you can calculate with without even a calculator. So the question aiming usually to test your knowledge about the contingency table and if you can fill it right. So after filling the 2 by 2 table, the totals are, as I said, easy to calculate, and the odd ratio is the topic of this presentation. And let's see how we can calculate the odd ratio. So typically, the odd ratio is used in case control studies, because the question might ask you what is the type of this study. And if you go back and read the question again, the question says that we have number of cancer patients. That means we know the cases. We know that these patients have lung cancer. That means they are cases. And they give us that we have 80 non-cancer. So that means those were the controls. And the aim of that study was to understand how many of the patients who have cancer were smokers and how many of the non-cancer patients were smokers as well, to understand the relationship and the percentages of the smoking effects on lung cancer. So this is also simple but crucial understanding of the type of study. Case control, that means we have the cases from the beginning. We know we have cancer patient and non-cancer. These are the cases and the controls. So the odds of exposures in cases, that means the smoking in cancer patients, versus the odds of the exposure in controls, which is the smoking in non-cancer patients, is literally the odd ratio. So odd ratio is getting the odds of the cases and divided by the odds of the control, and that's what's basically called the odd ratio. Let's do that practically. So as we filled the 2 by 2 table, we have 15 smokers, 5 non-smokers, total 20 cases. So the odds of exposure in cases is 15 divided by 5, which is A divided by C. And that literally means out of the 20 patients, they were 15 smokers. That means the exposure odds is 3. All right, let's go to the odds of exposure in the controls. And I will put here the 2 by 2 table, leaving only the non-cancer patients. And to calculate the odds of the controls, we divide the B by D, because we are just studying non-cancer patients, right? So we focus on that column. We divide the 30 by 50, which is 0.6. To have the odd ratio, we have to divide the odds that we calculated for cases by the odds we calculated for controls, which means we have to divide the 3 we got here by 0.6, which we have here, and the answer is 5. That's the odd ratio for that question that we have. It's, yes, simple, but we have to understand the concept first. We got the odds of exposure, which means we divide the number of smokers by the number of non-smokers. And we divide the number of smokers and non-smokers for the controls as well. And then we divide both together. There is another way to calculate the odd ratio, and I will discuss that in the next slide. Okay, as I said, there is another way to calculate odd ratio. We have the same 2 by 2 table, and we do simple math. We said the rule for the odd ratio is A by C divided by B by D, right? The odds for the cases divided by the odds for the controls. So by simple math, when we have two fractures divided by each other, we can change it into multiplication by reversing the second fracture, right? So we'll keep the A divided by C as it is, and we reverse the second fracture and change the multiplication, the division sign to multiplication sign. So the same equation is equal to A over C multiplied by D over B. So That means A, D, or A multiplied by D divided by B, C, or B multiplied by C. It's simple math. I know doctors are not the best mathematicians, but this is high school math or even less than that. And you do the math. A multiplied by D is 15 times 50. This is divided by B multiplied by C, which is 30 times 5. And the answer is 750 divided by 150, which is 5. And that's the same answer that we got in the beginning. So whatever convenient for you, this is the way you calculate the odd ratio. Either you divide the A by C and then divide it by B by D, or do the multiplication if it's easy for you. I find the multiplication easier and it's a shortcut. You just fill the 2 by 2 table and then multiply A by D, the same X you see here on the screen, A multiplied by um, uh, D, which is 15 times 50, divided by B times C, which is 30 times 5. I hope this is simple enough to explain how to calculate the odd ratio. And literally, we need to interpret the odd ratio because calculation is one step. Sometimes they ask you the interpretation. They give you many options and they ask you to pick the correct interpretation. So what it means that the odds of exposure in cases versus the odds of exposure in control were 5, and that's interpreted as patients with lung cancer are 5 times more likely to have a history of smoking. Why we label it like this? Because remember, it's a case control study. We start with the patient all the time, and we say that the patient who we know have lung cancer are 5 times more to likely be smokers or have history of smoking in comparison to the non lung cancer patients. That's the way to interpret the odd ratio. I hope this was a helpful presentation, and we'll keep doing practical examples like this in the coming presentations. Thank you so much, and don't forget to subscribe to my YouTube channel. Goodbye.